Welcome, dear friend, to Luminous Uplift, a quiet place where wonder and serenity walk hand in hand, guiding you gently toward rest. If today felt heavy, if the hours stretched long and the world moved a little too fast, we are so glad you found your way here. Set down whatever you have been carrying. Let your shoulders soften, let your breath slow, and allow this moment to belong entirely to you. Here at Luminous Uplift, we believe that the greatest stories are not always the ones that excite. They are the ones that fill you with a soft, glowing sense of awe. We gather those stories carefully, like starlight cupped in open hands, and we offer them to you as a gift at the end of your day. Tonight, we turn our eyes upward and outward, drifting far beyond our own familiar sky. We travel not in haste, but in a slow, dreaming arc across the darkness, moving toward a faint smudge of silver light that has watched over our nights for billions of years. That light belongs to Andromeda, our closest galactic neighbor, a vast and breathtaking spiral of ancient suns quietly sailing through the cosmos beside us. We will wander gently through her mists, tracing the soft curves of her arms and resting in the calm enormity of her presence. If these peaceful journeys bring you comfort, we warmly invite you to like and subscribe so we may continue meeting you here night after night in this little corner of the cosmos. Now, let us begin our journey together into the luminous heart of Andromeda. Close your eyes for just a moment, and then, very slowly, open them again. Imagine that above you, there is no ceiling, no roof, no shelter of any kind between your resting body and the great open cathedral of the night. Imagine that you are lying on soft ground, perhaps cool grass still holding the faint memory of an afternoon sun, or dry desert earth that breathes warmth back into the darkness like a living thing. The air around you is still. The world has grown quiet in the way it only truly does in the deep hours, when the last lights of human busyness have dimmed and the sky has finally been given permission to show itself fully, completely without competition. Now look up. Take your time. There is nowhere to go tonight, nothing to do, no destination to reach. You have arrived. This moment, this stillness, this looking upward into an ocean of soft and distant fire, this is the destination. And what spreads above you is not emptiness, as it might first appear to a hurried glance. It is not absence. It is the most extraordinary presence you could ever hope to rest your eyes upon. A tapestry of light and time and distance so immense that the human mind, even at its most awake and alert and reaching, can only touch the very outermost edge of it, the way a child reaches a fingertip into a tide pool and feels, just barely, the vast cold ocean waiting beyond the shore. Let your eyes soften. Do not search for anything yet. Simply receive. Let the darkness pour in around the points of light. Let the stars settle into your awareness the way music settles into a room, gradually filling every corner until you cannot quite remember what silence sounded like before. Some stars are brilliant and sharp, burning with a kind of blue-white confidence that suggests great heat and great distance all at once. Others are gentler, warmer, the color of candlelight or embers, the color of something older and slower and more patient. And between them, threading between every point of brightness, is the dark. Not an empty dark, but a rich one, a layered one, a dark that goes back so far and contains so much that it becomes its own kind of presence. This is the night sky, and it has been waiting for you, Breathe in slowly. Feel your body settle. Let your shoulders drop and your thoughts loosen their grip on the day that has just passed, on all its small urgencies and necessary worries, and the thousand things that asked for your attention and received it. They will be there tomorrow if they need to be. Tonight, they can rest. Tonight, you can rest here, under this impossible canopy, this ceiling made of time itself. Now, if you know where to look, and we will find it together, very gently without rushing, there is something waiting for you in the night sky tonight that is unlike anything else you could ever hope to see. It does not blaze. It does not command the eye the way certain stars do. Those brilliant anchors of familiar constellations that draw the gaze like a lighthouse draws a ship. No, what we are looking for tonight is subtle. It is shy. It is patient in the way that only truly ancient things can be patient, as if it has been waiting so long that waiting has become simply the nature of its being, the quiet texture of its existence. We are looking for a galaxy, not just any galaxy. The galaxy, the one that, of all the hundreds of billions of galaxies scattered across the observable universe, is the single most distant object that your own unaided eyes, these remarkable and tender instruments that have been with you since the very first moment of your life, are capable of detecting. No telescope, no technology, no lens ground by human hands. Just your eyes and the night and the light that has traveled so far and for so long to reach you that the journey itself defies every intuitive sense of scale you have ever developed. Her name is Andromeda. You will find her by looking first toward a familiar shape in the autumn sky, a great square of 4 bright stars that astronomers have long called the Square of Pegasus. That mythological winged horse whose constellation rides high in the evening hours when the year is turning toward its cooler, quieter self. From one corner of that great square, a chain of stars curves away like a gentle arc, like the graceful gesture of an arm reaching outward. This is the constellation of Andromeda herself, named for a princess from the rich and endlessly imaginative world of Greek mythology, a young woman of extraordinary grace and unfortunate fate, chained to a sea cliff as an offering to a monster, saved at the last possible moment by a hero on a winged horse. The stars that carry her name have been her companions across the centuries, patient witnesses to all the stories that human beings have poured into the night sky in their long effort to make sense of the darkness above them. Follow that arc of stars, and there, hanging near the middle of that gentle chain, if the night is truly dark and your eyes have had time to adjust, if you have been patient enough and the sky is kind enough, you may begin to notice something that is not quite a star. It does not resolve into a sharp point the way stars do. It is more like a breath on cold glass, a softening of the darkness, a faint and feathery smudge of the palest light you have ever seen. So delicate that looking directly at it can make it seem to disappear, so that you must learn the old astronomer's trick of averted vision, of looking slightly away, letting it fall on the more sensitive edge of your eye's field, and there, in that gentle sideways glance, it remains, a soft luminescence, a whisper of light. That is Andromeda. That is M31, as astronomers call it in their catalogs, the 31st entry in the great list compiled by the 18th century French astronomer Charles Messier, who was hunting for comets and kept being distracted by these frustrating fuzzy objects that were definitely not comets, and who could not have known, not in any meaningful sense. that one of the blurry nuisances cluttering his sky survey was in fact a twin of the very galaxy he stood inside. But we will come to that later. For now, simply hold it in your awareness. That faint smudge, that soft exhalation of light near the Andromeda constellation, and understand that what you are seeing is not a star, not a nebula in any simple sense, but an entire galaxy. A vast and spinning city of stars so enormous that if you could somehow see it clearly, if you could strip away the distance and the darkness and the limits of human vision, it would appear in the sky roughly 6 times wider than the full moon. 6 times wider than the full moon, and yet we see it only as that faint smudge, that breath of light, because of the unimaginable distance between us. How far away is Andromeda? The number exists, and it is precise, measured by generations of astronomers using methods of extraordinary ingenuity. Methods involving the rhythmic pulsing of certain stars that act as cosmic measuring sticks, reliable and calibrated across the depths of space. Andromeda is approximately 2.5 million light-years away from us. 2,537,000 light-years, to give it more of its full dignity. A light-year, remember, is the distance that light travels in a single year, and light travels at the fastest speed the universe permits, nearly 300,000 kilometers in a single second. So fast that it could circle the entire Earth more than 7 times in the time it takes your heart to beat once. And Andromeda is 2.5 million of those years of traveling at that speed away from us. Lay that distance out in your mind and feel it dissolve into something that numbers can gesture toward but never quite contain. And yet, on a clear, dark night, far from the glow of cities, you can see it. Your eyes, without any help at all, can detect the ancient light that has crossed that incomprehensible gulf and arrived here at this night, at this field or hillside or desert, and entered the small dark opening of your pupil and come to rest on the thin layer of cells at the back of your eye that translate light into experience. This is one of the quiet miracles of existence, so quiet that it passes unnoticed by nearly every human being who has ever lived, even as it happens to every person who has ever stood beneath a dark sky and looked toward the right corner of the night. Long before we understood what Andromeda was, before we understood that it was a galaxy in its own right, and not simply a cloud of gas within our own stellar neighborhood. Human beings had been noting its presence in the sky, recording it, giving it meaning. In the year 964 of the Common Era, a Persian astronomer of extraordinary brilliance named Abd al-Rahman al-Sufi included Andromeda in his monumental work, the Book of Fixed Stars, a text that brought together centuries of astronomical observation and organized it with a care and precision that would not be surpassed for generations. Al-Sufi described what he saw as a little cloud, a nubecula, and in doing so became the earliest known observer to document this distant galaxy in writing. Though of course the people who gazed at those same stars before him, in every culture and on every continent where dark skies permitted, surely noticed that soft anomaly in the constellation. Even if no record of their noticing has survived the long erosion of time, think of that for a moment. More than 1,000 years ago, a man in Persia, working in a tradition of scholarship that stretched back centuries before him, looked up at the same sky you're looking at tonight, found the same faint smudge of light near those same stars, and wrote it down. He did not know, could not have known, that he was looking at another galaxy. The very concept of a galaxy, in the way we understand it, would not exist for nearly another 1,000 years. He saw a cloud. He saw something that did not quite belong to the star field around it, something soft and diffuse and slightly apart. And he wrote it down with the same careful attention to the real that all great scientists share across every culture and every era. The willingness to observe what is actually there, rather than what one expects or hopes to find. What he wrote down was the light of 2.5 million years of travel. What he recorded in his elegant script was a message that had been moving through the darkness since before his civilization existed, since before the pyramids rose from the Egyptian desert, since before the first cities grew up along the Tigris and the Euphrates, since before human beings had developed the art of writing itself, which is the very art he was using to record it. Because the light that reaches your eyes tonight from Andromeda, that faint and gentle smudge near the Princess constellation, that light left its home stars roughly 2.5 million years ago. It began its journey across the universe before our species existed in any form we would recognize as ourselves. Modern humans, Homo sapiens, have walked this earth for roughly 300,000 years, perhaps a little more depending on how you draw the boundary of the term. That means the light you're seeing tonight left Andromeda approximately 8 times longer ago than our entire species has been alive. When that light began its crossing, our ancestors were early members of the genus Homo, perhaps Homo habilis. Small-brained and stone-tooling beings living in the grasslands and forests of eastern Africa, looking up at the same stars, but not yet able to form the thought that what they saw might be something to understand, rather than simply to fear or to worship or to use for navigation. The light left. It traveled. The earth kept turning. Continents drifted by fractions and inches that accumulated into miles over the vast, slow timescale of geology. Ice ages came and retreated. Species appeared and went quiet. The ancestors became us, slowly, generation by generation, and we learned to speak, and then to sing, and then to build, and then to write, and then to wonder in the formal, systematic way that we call science. And through all of that, through every heartbeat of every creature that ever lived on this spinning rock, the light kept coming, crossing the dark, closing the distance, moving toward a night that had not yet happened, toward eyes that had not yet evolved, toward you, lying here in the gentle dark. And as your eyes grow heavy and the darkness softens around you, that faint smudge of light overhead carries within it a story so vast and so ancient that even the word ancient feels too small. Because that light began its quiet journey toward you long before, and as your eyes grow heavy and the darkness softens around you, that faint smudge of light overhead carries within it a story so vast and so ancient that even the word ancient feels too small. Because that light began its quiet journey toward you long before our species had learned to wonder, long before the first human hands had pressed their shapes into cave walls, long before anyone had looked up into the darkness and felt that particular ache of curiosity that still lives in you tonight. Let us follow that light. Let us trace it gently, the way you might trace a line in the sand with your fingertip, slowly and without hurry. Because this is not a story that asks anything of you except to breathe and to listen and to let your body grow a little heavier with each passing word. The light that you might glimpse on a clear night, that soft and milky smudge sitting in the constellation of Andromeda, is traveling toward you at a speed so extraordinary that the human mind can only approach it sideways, the way you approach a fire, not too directly, but close enough to feel the warmth. Light moves through space at approximately 299,792 kilometers every single second. That is not a number that means very much when you first hear it, so let us sit with it for a moment the way you might sit with a piece of music, not trying to analyze it, simply allowing it to pass through you. In 1 second, a photon of light could travel around the entire Earth more than 7 times. In the time it takes you to exhale one slow and sleepy breath, that light has already crossed a distance that no spacecraft we have ever built could travel in a lifetime. And yet, even at that almost incomprehensible speed, the light from the Andromeda Galaxy takes 2,537,000 years to cross the space between that distant island of stars and the waiting quiet of your eyes. 2.5 million years. More than 2.5 million years of traveling through the dark, through silence, through a cold and velvet emptiness that stretches so far between the galaxies that even our most careful measurements feel like estimates whispered into a very large room. To understand how far that really is, consider for a moment what we call a light year, which is simply the distance that light covers in one full year of traveling at its extraordinary speed. A single light year is approximately 9.46 trillion kilometers. Not 9 trillion, not even 10 trillion. 9.46 trillion. It is a number so large that it has passed beyond the realm of counting and entered the realm of feeling. The way the ocean feels large, not because you have measured it, but because you have stood at its edge and understood somewhere below thought that it extends far beyond what you can see. And the Andromeda Galaxy sits 2.5 million of those light years away from where you are lying right now, your breath slowing, your thoughts beginning to soften at their edges like watercolors left in the rain. That distance, that almost sacred expanse between our galaxy and the nearest great galaxy to our own, has a name in the language of astronomers, though the name itself is not what matters tonight. What matters is the quality of that space, the texture of the silence through which those ancient photons have been traveling for longer than our species has existed. The region between galaxies is called the intergalactic medium, and it is, by almost any measure, the closest thing to true emptiness that the universe contains. If you were to take a cubic meter of that space, a box about the size of a washing machine, and examine everything inside it, you would find only a few atoms. Perhaps 1, perhaps 2, perhaps 3, scattered like the last crumbs on a very large table. The air in the room where you're resting right now contains something closer to 10 million trillion atoms in that same volume. So many atoms that they are constantly brushing against your skin, filling your lungs, pressing gently against your eyelashes. But out there in the intergalactic dark, between the Andromeda Galaxy and the Milky Way, there is almost nothing at all. Just the occasional lone atom drifting in the cold, and through that extraordinary emptiness, those ancient points of light have been crossing, patient and uninterrupted, for longer than the human story has existed on this planet. And here's the detail that has a way of settling something deep inside the chest, something that quiets the busy mind better than almost any other thought. The photons that are arriving from Andromeda tonight, the ones that are even now making their way toward Earth through the last thin veil of our own atmosphere, were emitted from their parent stars at a time when Homo erectus walked this planet, not our species, not Homo sapiens, not the people who built cities and wrote poetry and looked up at the night sky with telescopes and questions. Homo erectus, our older relative, our predecessor, a being who stood upright and carried tools and moved across the ancient landscapes of Africa and Asia in ways that suggest thought, suggest curiosity, suggest the very beginning of something that would eventually become the creature lying here tonight in the comfortable dark, listening to a story about starlight. When those photons first left the stars of Andromeda, there was no language on this earth. There were no words for what those beings saw when they looked up into the night. There were perhaps only the feelings that words eventually learned to name, wonder, and smallness, and that strange and tender sense that the dark above is not empty, but full of something almost too large to hold. And from that moment, from that very breath of light leaving those distant suns in a galaxy we would not name for millions of years to come, those photons began their crossing. They moved through the intergalactic medium with nothing to slow them, nothing to scatter them, nothing to disturb the quiet precision of their path. They moved while the ice ages came and went on Earth, while the ancestors of every living thing shifted and changed and found new forms. They moved while the first members of our own species began to appear, while language slowly gathered itself from gesture and breath and feeling. They moved while we discovered fire in new ways, while we painted animals on cave walls by the light of lamps made from animal fat, while we crossed land bridges and sailed reed boats and looked up at this same sky and began to tell the first stories about what the stars might mean. All of that time, those photons were crossing the dark. All of those years, that light was on its way to you. There is something in that thought that has a quality very much like being held, not held by a person, but held by time itself, by the long and patient architecture of the universe, which does not hurry and does not need to, because it has all the time that time can contain. You have been resting here for only a few minutes, perhaps, and already you may feel the particular heaviness that comes when the body begins to understand that sleep is near, that soft and necessary falling that happens every night and is in its own way a small surrender to the dark. And those photons, those ancient travelers, have been doing something not entirely unlike falling for 2.5 million years, falling forward through space, drawn by nothing but their own momentum and the undisturbed straightness of their path through a universe that is expanding even as they cross it. Light does not tire. Light does not slow. There is nothing in the intergalactic medium significant enough to stop it or even to bend it very much. Only that sparse and ghostly scattering of lone atoms that barely registers as an obstacle, that barely notices as those photons pass through one by one in an unbroken stream, a stream of light that has been continuous for all of human history and long before it. A river of ancient photons that crosses the void between galaxies as quietly and as persistently as a very slow and very gentle tide. When those photons finally reach the Earth, they have one more small journey to make. They must pass through the atmosphere, through layers of gas that grow thicker as they descend, through air that scatters and shifts and bends light in ways that give us sunsets and blue skies, and the soft blurring of stars near the horizon. And then, if you're outside on a clear night, lying on your back with your eyes open and your breathing slow, those photons may find the dark circle of your pupil and pass through the curved lens of your eye and travel the last small distance to the back of your retina, where they will meet a layer of cells that have been waiting for exactly this kind of visitor. In your retina, there are cells called rods and cones, and within them, there are molecules called photopigments. And when a photon from Andromeda strikes one of those molecules after its 2.5 million year crossing, something extraordinary happens. A chemical reaction begins. A cascade of signals travels down the optic nerve and into the deep and intricate forest of the brain. And somewhere in that process, in that biochemical conversation happening entirely without your conscious effort or awareness, an experience arises. You see, you perceive, you become, for one quiet moment, the endpoint of a journey that began before anyone on Earth knew what a journey was. The philosophers have a word for this, for the moment when the physical world becomes an experience inside a mind. But tonight, we do not need the word, because you are already living it, already lying here at the end of an invisible thread that stretches back 2.5 million years through perfect darkness and nearly perfect emptiness to a galaxy that contains roughly 1 trillion stars, each of them burning with the same indifferent and beautiful abundance as our own sun. The Andromeda Galaxy is not small. It is larger than our own Milky Way, stretching across a span of sky that, if our eyes were sensitive enough to see it fully, would appear to be 6 times wider than the full moon. It is a vast and ancient system of light and gravity and gas and stars and the dark matter we cannot see but can only infer from the way things move, and all of it. All of that complexity and depth and unimaginable scale has been sending its light in all directions for billions of years, and some of that light, a tiny and particular fraction of it, has been aimed without aim in the direction of a small rocky planet circling an ordinary star on the outer arm of a spiral galaxy, and on that planet a creature has developed eyes. And tonight that creature is lying still and breathing slowly and looking perhaps at a smudge of ancient light in the dark and in the retinal cells of that creature. A chemical reaction is beginning, and that tiny chemical miracle happening behind your eyes is the last chapter of a journey so impossibly long that even now, resting here in the quiet dark, it feels less like science and more like something that was always meant to arrive just for you. Traveling through the vast and velvet silence of intergalactic space where almost nothing exists. Almost nothing stirs, and yet somehow the universe is not as empty as the word empty implies. And this is something worth sitting with for a moment. Worth letting settle into your breathing the way a soft weight settles into a mattress at the end of a long and wandering day. Because between us and Andromeda, between the spiraling arms of our own galaxy and the spiraling arms of that distant sister turning slowly through the dark, there is always something. The universe, it turns out, does not know how to be truly empty. Not in the way we might imagine emptiness, not in the way a room feels empty when the last light is switched off and you're finally alone with the quiet. No, the space between galaxies has its own kind of presence, its own kind of whispered fullness, and if you were to somehow travel through it, to drift across those millions upon millions of light years in the darkness between the Milky Way and Andromeda, you would be moving not through nothing, but through something ancient and diffuse and almost impossibly thin, a substance so faint it barely deserves the word substance at all, and yet it is there. It is always there. Scientists call it the intergalactic medium, which is perhaps one of those phrases that sounds more clinical than it deserves to, because what it really describes is something closer to a dream of matter, a ghost of gas and particles stretched so thin across such incomprehensible distances that in any given cubic meter of that space you might find only a single hydrogen atom, drifting alone, patient, waiting for something that may never come. And yet, in the aggregate, across all those light years, across all that dark and velvet distance, there is enough of this diffuse material to matter, enough to carry information. enough to be moved by forces greater than itself, shaped by gravity, threaded through with mystery, part of the great invisible architecture that holds everything together in ways we are only beginning to understand. And so as you rest here, as your breath slows and your body remembers the pleasure of stillness, imagine that medium surrounding you not as absence, but as presence. Imagine all that space between here and Andromeda, not as a void, but as an ocean so vast and so calm that its waves, if you could call them that, would take millions of years to crest and fall. You are resting at the bottom of something immense. The intergalactic medium is above you and below you, and in every direction the word direction can possibly stretch, and it is resting too in its own way. In the only way matter knows how to rest when it has been spread across the universe so thinly that time itself seems to move differently there, slowly, gracefully, with the patience of something that has never had anywhere urgent to be. But the gas is not alone out there. Nothing in the universe is ever truly alone. And this is one of those quiet scientific truths that feels in the right light, less like a fact and more like a kind of comfort. Woven through that diffuse intergalactic medium, invisible yet undeniably present, is dark matter, which does not shine and does not reflect, which cannot be seen by any telescope we have ever built or dreamed of building, and yet which makes its presence known through the way it bends and curves and sculpts everything around it. Scientists understand dark matter primarily through its gravitational fingerprints, the way galaxies rotate in ways they should not if they contained only visible matter, the way light bends as it passes through regions of space that appear to our instruments as completely empty. Something is there. Something massive and pervasive and ancient is threading itself through every corner of the cosmos, and between the Milky Way and Andromeda, it forms part of a structure so grand and so intricate that astronomers gave it a name that feels almost mythological: the cosmic web. Think of it as a web spun not by any spider, but by the universe itself across 14 billion years of patient work. A web made not of silk, but of dark matter and gas and gravity. Filaments stretching between clusters and superclusters of galaxies, connecting everything to everything else in a structure that, when mapped across the observable universe, looks remarkably like the inside of a living mind, like neurons firing, like the branching of rivers seen from very far above. The cosmic web is perhaps the largest structure in existence, and we live within it, embedded in one of its glowing nodes. And the space between us and Andromeda is not outside this web, but threaded through it, part of it, held by it, a stretch of something that looks like emptiness, but is in fact a filament of connection, dark and diffuse and running with quiet purpose between two galaxies that have never stopped belonging to each other. Because we do belong to each other. The Milky Way and Andromeda are not strangers passing in some incomprehensible cosmic night. They are neighbors in the deepest sense of that word, bound together within a structure called the local group, which is the name astronomers give to our small collection of galaxies here in this corner of the universe. The local group spans roughly 10 million light-years across, and within that span, there are approximately 54 galaxies of various sizes and temperaments, some large and spiraling like our own, some small and irregular and dimly glowing satellites and companions and wanderers that have been gravitationally gathered into this loose family over billions of years. 54 galaxies, each one a city of stars, each one containing worlds we have never seen and may never see, and all of them together forming a community held in place by the same invisible architecture, the same patient gravitational bonds that connect the Milky Way and Andromeda to each other. Among the members of this family, drifting in the space between the two great spirals, there are galaxies that sometimes get overlooked in the sheer vastness of the larger story, smaller galaxies, quieter ones, that nonetheless have their own beauty and their own importance. The Triangulum Galaxy is one of them. The third largest in the local group, a spiral galaxy in its own right, though smaller and less defined than either of its larger neighbors. Visible on the clearest nights as a faint smudge of light near the constellation Triangulum, if you know where to look, and if the sky above you is dark enough and the air is still. The Triangulum Galaxy sits roughly between us and Andromeda, part of the same cosmic family gathering, and it may be gravitationally bound to Andromeda, orbiting it in a slow and stately dance that has been going on for longer than the Earth has existed. And beyond the Triangulum Galaxy, there are dwarf galaxies too, small and faint and numerous satellite galaxies that cluster around the larger spirals like moons around planets. Each one a world of stars too faint and too distant to see with any unaided eye, but present nonetheless, real nonetheless. Part of this family that stretches across 10 million light-years of cosmic space and contains within it everything we have ever known or imagined. It helps perhaps to think of the local group, the way you might think of a neighborhood seen from a great height, seen from so far up that the individual houses are invisible, and all you can perceive are the warm lights clustered together against the dark. Here a bright glow, there a dimmer one, and between them streets and paths that you cannot quite make out, but that you know are there because nothing in a neighborhood exists in isolation. The streets between galaxies are the cosmic web, the intergalactic medium, the dark matter filaments that connect every point of light to every other. And within this neighborhood, the two brightest lights, the two most luminous presences, are the Milky Way and Andromeda, separated by roughly 2.5 million light-years of this diffuse and beautiful nearness that we call emptiness, but that is, as we have been learning together in this gentle darkness, really something else entirely. 2.5 million light-years. Let that distance settle into you softly, the way warmth settles into hands held near a fire. The light that left Andromeda when our ancient human ancestors were first learning what it meant to walk upright on the African savanna is only now reaching your eyes, and when it arrives, when it crosses all that impossible distance and touches your retina, it tells you something about a galaxy that existed millions of years before you were born, a galaxy that has changed in the time that light was traveling. That is different now from what you're seeing, and yet which is, in some fundamental sense, the same swirling collection of hundreds of billions of stars it has always been, spinning slowly, shining steadily, moving through the dark with a purpose that gravity has made inevitable. Because Andromeda is moving toward us, not rushing, not hurtling, not in any way that should trouble your rest or quicken your breath, but moving nonetheless, drawn by the same force that keeps your body resting here on the surface of this small warm planet instead of drifting up into the night. Gravity, that most fundamental and patient of all forces, the one that speaks across the largest distances, the one that does not need light or sound or any medium to carry its message, the one that works through the intergalactic medium and through the dark matter web and through all those millions of light years of diffuse and ghostly gas to hold these two great galaxies in a relationship that has been developing for longer than most of the stars in either galaxy have been alive. Andromeda and the Milky Way are gravitationally bound to each other, locked in a slow cosmic embrace that nothing in this universe has the power to break. Not distance, not time. Not the expansion of space itself, which pulls most distant galaxies away from each other, but which cannot overcome the gravitational bond between two objects as massive as these two great spirals. They are already committed to each other. They have been committed to each other, scientists believe, since the very early universe, since matter first began to gather and cluster and form the seeds of what would eventually become galaxies. And now across 2.5 million light years, they feel each other's pull. They always have, and that pull grows infinitesimally slowly by human reckoning, but with perfect consistency and certainty, a little stronger with every passing year, a little more insistent, a little more like an answer to a question the universe has been asking for a very long time. There is something deeply, quietly beautiful about this, something worth resting inside as your eyes grow heavier and the thoughts that ordinarily crowd your waking mind begin to thin and soften and separate from each other, like clouds moving apart to show the stars beneath. The idea that gravity is not merely a force, but a kind of tenderness, a kind of slow and wordless reaching. Two enormous collections of light and gas, and billions of individual suns, and the countless worlds orbiting those suns, all of it reaching toward all of something else, patient and inevitable. Across millions of light years of the cosmic web and the intergalactic medium and the dark matter that holds everything in its invisible embrace. It is not a collision waiting to happen, though someday it will be that too, in its own time and in its own gentle way. Right now, it is simply a drawing together, a gravitational bond so patient, so inevitable, that it does not hurry and does not rest. Simply drawing two great spirals of light toward each other across millions of years, the way sleep draws you now, gently and without resistance, into something larger than yourself. And it is within this impossible tenderness of gravity that the true nature of Andromeda begins to reveal itself, a galaxy that is not so different from our own, a great spinning, a gravitational bond so patient, so inevitable, that it does not hurry and does not rest, simply drawing two great spirals of light toward each other across millions of years, the way sleep draws you now, gently and without resistance, into something larger than yourself. And it is within this impossible tenderness of gravity that the true nature of Andromeda begins to reveal itself, a galaxy that is not so different from our own, a great spinning wheel of light and shadow and ancient fire, structured with a kind of cosmic elegance that is almost too beautiful to hold in the mind all at once. And yet here we are, drifting toward it together in the dark, letting its architecture unfold before us. The way a cathedral reveals itself when you step through its doors and look upward and realize that human hands once reached this high, that something inside us has always wanted to build toward the infinite. And Andromeda is just such a cathedral, built not by hands, but by gravity and time, assembled over billions of years from the raw and shining material of the early universe. A structure so vast and so precisely arranged that even at this distance, even across 2.5 million light years of breathing space, we can trace its outline with our instruments and feel something stir inside us that is older than language. Let us begin at the very heart of it, because every great structure has a center, a place from which everything else radiates outward. And Andromeda's center is something extraordinary. A region of such density and brightness that it glows like a captured sun, even from our distant shore of the universe. The central bulge of Andromeda is a swelling of ancient starlight, a rounded luminous core, packed with stars that are old beyond reckoning. Stars that were born in the early chapters of cosmic history, when the universe itself was young and turbulent and thick with the raw ingredients of creation. These are not the young blue stars of active star-forming regions, not the bright and fleeting fires of recent birth, but the warm, amber-colored elders of the galactic world, red and orange giants that have been shining steadily for billions upon billions of years, their light patient and enduring, like the light of a lamp left burning in a window for someone who has been away a very long time. The bulge of Andromeda swells gently outward in all directions from the core, a soft and luminous sphere of accumulated history. And it is within this bulge that the oldest stories of the galaxy are written, pressed into the light of stars that remember a universe we will never see. And at the very center of that bulge, deeper in than the oldest stars, hidden behind veils of gas and dust, and the sheer weight of accumulated matter, there is something else, something that does not glow but devours, something that does not radiate but accumulates with a patience that makes even the stars seem hurried. At the heart of Andromeda there rests a supermassive black hole, known to astronomers by the quiet designation Messier 31 star, a name that sounds almost gentle for something so absolute. And this black hole carries within its invisible boundary a mass approximately 100 million times greater than our own sun. 100 million solar masses compressed into a point of such extreme density that space itself curves around it like water spiraling slowly down a drain. And time near its edges bends and stretches in ways that make the ordinary passage of moments meaningless. 100 million suns. Let that settle over you the way a warm blanket settles over the shoulders on a cold night. Not with alarm, not with urgency, but with the quiet recognition that the universe is capable of scales that the human mind can only approach sideways through metaphor and surrender, through the gentle release of trying to contain what cannot be contained. This black hole does not announce itself. It sits at the center of its trillion-star kingdom in perfect stillness, holding everything together through the invisible architecture of its gravity. A silent conductor whose orchestra plays on without a single visible baton stroke, and around it the galaxy turns, slowly and endlessly, like a dream that knows it is a dream and continues anyway. Andromeda is estimated to contain roughly 1 trillion stars. A trillion, the number itself, is a kind of poetry, a word that sounds like distance, that sounds like the space between sleeping and waking, when the mind is still partly in the dream, and the ceiling above you looks briefly unfamiliar and then returns to itself. 1 trillion stars. And some estimates suggest there may be even more, that Andromeda may hold twice as many stars as our own Milky Way, which we have always thought of as enormous, which we cannot cross in a human lifetime, even at the speed of light, which spans 100,000 light years from one edge to the other, and takes our sun 225 million years to orbit just once. And yet Andromeda is larger still. It spans approximately 220,000 light years in diameter, a width so great that if you could stand at one edge and send a beam of light toward the other, it would travel for 220,000 years before it arrived. 220,000 years of nothing but light moving through space at the only speed it knows how to move. And still it would take that long. Still, that distance would ask that much of even the fastest thing in the universe. This is the size of the place we are drifting toward. This is the scale of our inevitable companion. And somehow, held inside this knowledge, there is not terror, but peace. The peace of understanding that you are part of something so much larger than any worry you have carried today. So much larger than the small and beautiful circle of your ordinary life. And that largeness does not diminish you, but holds you. The way deep water holds a swimmer who has finally stopped fighting and learned to float. Beyond the central bulge, Andromeda's structure opens outward into its most iconic and breathtaking feature, the sweeping, curving spiral arms that give this class of galaxy its name and its singular beauty. Andromeda is classified as a barred spiral galaxy, which means that cutting through its central region there is a bar of stars, a bright, elongated structure from which the spiral arms emerge and curve outward like the arms of a pinwheel caught in a slow and cosmic wind. This bar is not unusual among large spiral galaxies. Our own Milky Way has one too, and it speaks to the underlying dynamics of galactic structure. The way stars and gas and dark matter move and interact over billions of years, settling into patterns that are both random and ordered, both chaotic in origin and elegant in outcome. The way a river finds its path not through planning, but through the patient persistence of flow. From the ends of that bar, the spiral arms extend outward in great graceful curves, wrapping around the galaxy's center in a pattern that is not quite symmetrical, not quite perfectly geometric, but rather alive in the way that all natural things are alive, irregular at the edges, complex in the details, and yet unmistakably hauntingly beautiful when seen from far enough away. These spiral arms are not solid structures, not walls or rails along which stars are fixed, but rather regions of density, places where matter is slightly more compressed than elsewhere, where the interstellar medium thickens just enough to trigger the gravitational collapse that leads to star formation. And so the arms are traced in light, not because the stars live only there, but because the youngest and brightest stars are born there, blazing into existence and burning brilliantly before the arms have moved on, marking the path of the density wave the way foam marks the passage of a wave across the surface of the sea. And around all of this, around the central bulge and the bar and the glittering arcs of the spiral arms, there extends something less visible but equally extraordinary. Something that astronomers call the stellar halo, a vast and nearly spherical region of space that surrounds the disk of Andromeda like an atmosphere surrounds a planet, or like the quality of a dream surrounds its central image, present everywhere and in no single place, diffuse and enormous and quietly essential. The stellar halo of Andromeda is populated by older stars and by clusters of stars, scattered thinly through a volume of space so large that it extends far beyond the visible disk of the galaxy, reaching out into the intergalactic medium with a kind of gentle insistence, the galaxy making its presence known not only where it is brightest, but far out into the spaces where it fades almost to nothing. The halo contains the archaeological record of Andromeda's past, the ghostly streams of stars left behind by smaller galaxies that Andromeda absorbed long ago, pulled in by its gravity and slowly dismantled. Their stars scattered into wide-arcing orbits that preserve the memory of their former homes, the way a river preserves the shape of an ancient valley, long after the ice that carved it has melted and retreated. To look at the halo of Andromeda is to read a history written not in words, but in the positions of stars, in the subtle patterns of motion that betray ancient collisions and ancient absorptions, the long and continuing process by which a large galaxy grows larger still. And then there are the globular clusters. Oh, the globular clusters. These are among the most quietly magnificent objects in all of astronomy, and Andromeda possesses them in extraordinary abundance. Hosting at least 450 of these ancient spherical collections of stars, each one a tight and luminous ball containing hundreds of thousands of individual suns, bound together by their mutual gravity into a structure so stable and so enduring that many of these clusters are as old as the galaxy itself, as old as the universe's first billion years. Survivors of every upheaval and transformation that Andromeda has undergone across the vast sweep of its history. A globular cluster is not a loose and casual gathering, not a neighborhood of stars that happen to live nearby, but a true community gravitationally committed, orbiting its galactic center together the way a flock of birds moves through the air, each individual following its own path within the larger motion of the whole. And from our position in space, these clusters appear as soft blurs of concentrated light, small and round and ancient, like the embers of fires lit so long ago that the people who lit them have themselves become starlight. 450 of them orbit the heart of Andromeda, scattered through its halo and around its disk, each one a world unto itself. Each one containing hundreds of thousands of stars that have been companions through billions of years of cosmic time. And there is something unutterably peaceful in that image, in the thought of hundreds of thousands of stars bound together across billions of years, moving through the dark together, not arriving anywhere in particular, simply tracing their endless patient orbit around a center that holds them gently and does not let them go. The overall shape of Andromeda, when you hold it all in your mind at once, when you let the image of it form slowly behind your closed eyes, the way a photograph develops in a dark room, emerging gradually from formlessness into detail, is something that feels almost familiar, almost like looking into a mirror across an impossibly vast distance. It is inclined to us at an angle, Andromeda, tilted so that we see it not perfectly face-on, but at a slant, which means we can trace the slight thickening of the disk, the central swelling of the bulge rising above and below the plane of the spiral arms, and on long exposure photographs, the full sweep of it becomes visible. The galaxy extending across a portion of our sky far larger than the full moon, most of it invisible to the naked eye, but all of it there, all of it real, all of it wheeling through space in its own time with its own trillion points of light, doing the particular and unrepeatable things that stars do across their long and shining lives. And the thought of it, the sheer accumulated fact of it, can settle over you in the dark like something weightless and warm, like the knowledge that the universe did not have to be beautiful but somehow is, did not have to arrange its matter into spirals and halos and ancient glowing clusters but somehow did, and that we exist at a moment in cosmic history when we can look up and know what we are looking at, when we can call a thing by its name and trace its structure with our understanding and feel. In the tracing, something that is not so far from gratitude. Andromeda breathes. That is perhaps too simple a way to say it, but it is not wrong. It cycles through the processes of stellar life and death. It circulates its gas and dust through the mechanisms of star formation and supernova and the slow recollapse of expelled material. It has a rhythm that spans millions of years in a single beat. A rhythm we can only hear if we are willing to listen at the scale of geologic time, at the scale of cosmic patience. And when we listen that way, when we slow ourselves down to match even a fraction of that pace, the galaxy reveals itself not as a static picture, but as a living system, as dynamic and ongoing as a forest or an ocean, as full of change and continuity as anything that breathes and grows. And those spiral arms curving outward like the slowest breath ever exhaled by the universe are home to nurseries of new stars being born even as you rest. Clouds of hydrogen gas collapsing under their own weight in the deep quiet of space until something ignites, until light appears where no light was before. The same unhurried miracle of beginning that happens in every corner of Andromeda and has been happening there since long before our own sun was a thought, before the first light of our solar system had ever touched the dust and ice from which our own worlds would eventually form. And so when we turn our attention now to what happens inside those arms, to what is actually occurring within the slow and luminous curves of Andromeda as you lie here and let your breathing grow easier and your thoughts grow softer, we find something that feels almost tenderly familiar, something that resonates not with strangeness but with recognition, because the story of how stars are born in Andromeda is, in its most essential nature, the same story that gave us our own sun, our own warmth, the very light that has shaped every living thing on this small and beloved world. Imagine, if you will, a cloud. Not the kind of cloud you might watch drift across an afternoon sky, white and lazy and full of summer. No, imagine something far vaster and far quieter than that. Imagine a cloud made of hydrogen gas and dust. A molecular cloud so enormous that if you were to cross it traveling at the speed of light, you would still need hundreds of years to reach the other side. These are the giant molecular clouds that drift through the spiral arms of Andromeda, and they are among the most patient structures in the observable universe, hanging in the dark between the stars, like vast reservoirs of potential, like held breath, like something waiting at the edge of sleep for permission to begin. In Andromeda's spiral arms, these clouds can stretch for hundreds of light years in every direction, their boundaries soft and indistinct where the cool gas thins out into the surrounding emptiness. And within each one, within the cold interior where temperatures drop close to absolute zero, and where the dark is so complete that not even the faint glow of distant stars can penetrate, there is enough raw material to build not just one star, not just a handful of stars, but millions of them. Millions of suns sleeping in the dark, waiting for something to tip the balance, waiting for the slow accumulation of gravity to finally overcome the gentle outward pressure of the gas itself, so that pockets of the cloud begin to collapse inward, drawing more and more matter toward their centers, growing denser and warmer and denser still until the heat at the heart of the collapsing pocket becomes so extraordinary that the hydrogen atoms there begin to fuse and a star is born. This is what is happening right now in Andromeda. Not once, not a handful of times. Over and over in cloud after cloud, distributed across those long curving arms, this process of becoming is quietly underway. And the rate at which Andromeda transforms its gas into new stars is something astronomers have measured with considerable care, roughly 1 solar mass per year on average. A pace that is somewhat more restrained than the star-forming activity of our own Milky Way, which forges new stellar material at a rate of several solar masses each year. Andromeda is not hurrying. It never has been. It is a galaxy that seems in its current phase of life to be doing things gently, conservatively, at a pace that feels almost meditative when you sit with it long enough. And yet, even at that quieter rate, The birth of stars in Andromeda is an ongoing and wondrous thing. One solar mass per year means that every year, every slow turning of our planet around its star, Andromeda adds something new and burning to its collection of lights. A new fire in the dark, a new source of warmth and radiation that will burn for millions or billions of years, depending on how massive and how ambitious it chooses to be. The small and modest stars burn slowly and last an enormously long time, cooling and dimming only after billions of years have passed. The large and brilliant ones blaze with extraordinary intensity and live short, dramatic lives before exploding and scattering their heavy elements back into the gas clouds, from which the next generation of stars will eventually form. Even in their endings, stars are generous. Even in the act of dying, they are planting seeds. When you look at images of Andromeda, and there are images, extraordinary images, that the Hubble Space Telescope has gathered over years of patient observation, what you see in those spiral arms is color. Not the uniform silver-white glow you might expect from a galaxy seen edge-on, but genuine, unmistakable color that tells a story about age and energy and time. The young stars, the ones most recently born from those collapsing hydrogen clouds, burn hot and blue. Their light is energetic and short wavelength, and they trace the spiral arms of Andromeda the way foam traces the curl of a wave, marking the path where the density of gas is highest, where the conditions for stellar birth are most favorable. Look at one of Andromeda's arms, and you are, in a very real sense, looking at a road made of young blue light, a pathway of recent fire winding through the dark. And then there's the center. In Andromeda's central bulge, where the density of stars is highest and where the galaxy's ancient heart beats with a different rhythm, you find a different palette entirely. The stars there are older, redder, yellower, their light the warmer and more mellow signature of stars that have been burning for a very long time, that formed in Andromeda's early history, when the galaxy was young and energetic and full of gas to work with. These are not the fresh arrivals. These are the elders, the ones whose light has been traveling through Andromeda for billions of years, and their collective glow gives the bulge a warm amber quality, like embers rather than flame, like the last good light of an evening, rather than the sharp brightness of noon. The Hubble Space Telescope, in one of the most detailed and ambitious observations ever undertaken of a neighboring galaxy, has resolved more than 100 million individual stars in Andromeda's disk. Let that number settle gently into your mind as you rest. 100 million individual points of light, each one a sun, each one with its own history and its own trajectory and its own possible worlds, separated out from the general glow by the extraordinary resolution of that telescope and cataloged by astronomers who spent years processing the data. 100 million stars, and those are only the ones bright enough and well-positioned enough to be individually distinguished. The total number of stars in Andromeda is, of course, vastly larger than that, approaching something like 1 trillion when you account for all the dim and distant ones that blend together beyond the telescope's resolving power. But it is not only the stars themselves that carry color and meaning in Andromeda's star-forming regions. There is something else, something that glows with a warmth and softness that feels almost biological in its beauty. Some of the star-forming regions in Andromeda shine with a distinctive pink light, a rosy and gentle luminosity that comes from hydrogen gas that has been ionized by the radiation of the young blue stars burning at the heart of those regions. When a massive young star ignites, its radiation is so energetic that it strips the electrons from the hydrogen atoms in the surrounding gas. And when those electrons eventually recombine with the hydrogen nuclei, they emit light. The light they emit is characteristic and specific, a warm pink-red glow called hydrogen alpha emission, and it is one of the most recognizable signatures in all of astronomy. You find it in the Orion Nebula, in the Eagle Nebula, with its famous pillars of creation, in the Carina Nebula and the Lagoon Nebula, and in every other star-forming region we have studied in our own Milky Way. And you find it in Andromeda too, in exactly the same shade, with exactly the same chemistry, because hydrogen is hydrogen, whether it is 2.5 million light-years away or a few thousand. And the laws of physics are the same in every corner of the observable universe. This is one of the quiet and deeply reassuring things about looking at Andromeda. It is far, impossibly far by any human measure. And yet the pink of its star-forming clouds is chemically identical to the pink of the nebulae in our own galaxy. The young blue stars in its spiral arms form through the same process as the young blue stars in ours. The molecular clouds there are cold and dark and enormous, in exactly the same way that our molecular clouds are cold and dark and enormous. Whatever makes one galaxy different from another, they are all built from the same matter, following the same rules, participating in the same patient and ancient conversation between gravity and light and time. And there is something in that sameness, that deep structural kinship between one galaxy and another, that feels like a kind of comfort when you hold it close enough to really feel it. We are not alone in the architecture of our existence. The same story is being told in the same language, in thousands of galaxies, in every direction we look. Let yourself imagine, now, one of those star-forming regions in Andromeda as it might appear if you could somehow be near it, drifting quietly in the dark, a comfortable distance from the clouds themselves. The molecular cloud is immense, spreading out around you in every direction, its edges soft and gradual where the hydrogen thins into the surrounding interstellar medium. Deep in its interior, where you cannot see, gravity is doing its slow and inexorable work, drawing pockets of gas together, building the seeds of future stars in the cold and the dark. And at the edges of the cloud, where the most recently born stars have already ignited and are now burning with their fierce young energy, the gas is lit from inside, suffused with that warm and rosy hydrogen glow, pink and luminous and somehow gentle despite the titanic energies involved. The young stars themselves are brilliant and blue-white, their light energetic enough to ionize the gas around them and to push it outward in slow expanding shells, carving hollow cavities in the cloud, even as other parts of the cloud continue to collapse and build new stars of their own. It is a process of simultaneous creation and transformation, a kind of structured dynamic that turns one kind of thing slowly into another kind of thing. The way sleep turns the contents of a day into something reorganized and easier to carry. And somewhere in all of this, in the gradual translation of gas into stars and stars into light and light into the illumination of an entire galaxy's worth of spiral arms, there is something that feels, even at this scale, like a kind of nurturing, like the universe attending to itself, like matter finding the forms that allow it to shine. There is no mind directing it, no intention in the usual sense, and yet the outcome is this: warmth where there was cold, light where there was dark, complexity where there was simplicity. And eventually, after enough time and enough generations of stars enriching the gas with heavier elements, worlds where there might be something capable of looking back and wondering at all of it. The star-forming regions of Andromeda are nurseries in the most genuine sense. They are places where the future is being built, slowly, patiently, without hurry, in the unhurried dark. And those glowing pink clouds of hydrogen, lit from within by the fierce young stars they gave birth to, drift through Andromeda the way a dream drifts through the sleeping mind, full of color, full of becoming, and quietly dissolving at the edges into something cooler and older and darker where the ancient stars live, the ones that have been burning since almost the very beginning, each one carrying inside it the memory of a universe that was younger and hotter and perhaps more restless, and somewhere in that long, slow settling of time, those ancient fires found their place in the outer darkness, where Andromeda keeps her oldest secrets, the ones she has been holding since before the solar system existed, before the Earth had even begun to dream itself into being from the dust and gas that would one day become oceans and mountains, and the sleeping bodies of people who would one day lie in the dark and wonder about stars. Those oldest stars, the ones that live in what astronomers call the stellar halo, are not like the bright young stars of the disk, not like the fierce blue giants burning in the spiral arms, or the pink star-forming clouds still caught in the act of creation. These stars in the halo are quieter. They are slower. They carry a different kind of light, a more patient light, the kind that has been traveling for so long it has almost forgotten where it started. And when we look at them carefully, when we measure their ages with the delicate instruments of spectroscopy and let the language of light tell us its story, what we find is something that stops the breath for a moment with its sheer ancientness. These stars are estimated to be 10 billion years old. 10 billion years. The universe itself is only 13.8 billion years old, which means that when these stars were born, the universe was not even 3 billion years old. It was still in its early chapters, still working out what it wanted to become, still dense with heat and possibility, still very close to the fire of its own beginning. Try to hold that number for a moment, not as a number, but as a feeling. 10 billion years. When these stars ignited for the first time in the outer halo of what would become Andromeda, there was no sun. There was no Earth. There were no oceans, no continents, no single-celled organisms drifting in warm primordial seas. There were no dinosaurs, no mammals, no primates sitting in trees watching the moon rise. There was none of the long, patient story of life that we are part of. There was only the universe, younger and hotter and more restless, and somewhere in the darkness, a new star catching fire, beginning its long, slow burn that would continue across time so vast it becomes almost meaningless to the sleeping human mind. And yet here we are at the end of it. Or rather, here we are in the middle of it, breathing quietly in the dark while those same stars are still burning, still casting their ancient light outward into the halo, still remembering a universe we never knew. The halo itself is extraordinary. It is not something you can see easily, not something that appears in the photographs that show Andromeda's elegant spiral disk tilted toward us across space. The halo is more like a suggestion than a presence, a vast, diffuse cloud of old stars and ancient gas that surrounds the visible galaxy the way a dream surrounds the image at its center, present everywhere but difficult to focus on directly, and it is enormous, far larger than you might imagine. Andromeda's halo extends up to 1.3 million light-years from the center of the galaxy. 1.3 million light-years. The distance between the Milky Way and Andromeda is roughly 2.5 million light-years, which means that Andromeda's halo reaches more than halfway across the space between between our two galaxies. In a very real sense, the halo of Andromeda has already begun to touch the space around us, already reaching out across the darkness with its pale old light, already beginning the slow gravitational conversation that will one day draw the two galaxies together. But it is not only the age and the size of the halo that carries wonder in it. It is what the halo contains, what the halo remembers. Because encoded in the light of those ancient halo stars, in the specific wavelengths absorbed and emitted by atoms in their outermost layers, are what scientists call chemical fingerprints. Signatures of elements that tell us where those stars came from and what happened before they were born. And what those fingerprints reveal is something like a creation story written in the periodic table. Because the chemical composition of the halo stars in Andromeda carries the unmistakable signatures of ancient supernovae, enormous stellar explosions that happened before these stars even existed, that seeded the young universe with the heavy elements without which no rocky planet, no ocean, no living cell could ever form. In the very beginning, the universe made only the simplest elements: hydrogen and helium and a little lithium, the lightest and most basic ingredients, the raw material of the first stars. But hydrogen and helium alone cannot make a world. They cannot make iron or oxygen or carbon, cannot make the atoms of bone or blood or the neural pathways that dream. For those heavier elements, you need stars, and not just any stars, but the most massive ones, the ones that burn so hot and so fast that they forge heavy elements in their cores and then explode, scattering those elements outward into the surrounding gas clouds, so that the next generation of stars is born already enriched, already carrying inside them the remnants of a previous stellar life. And when we look at the halo stars of Andromeda and read their chemical fingerprints, we can see exactly this story written in their spectra. The ancient signatures of supernovae that happened more than 10 billion years ago, forging the heavier elements and releasing them into the galaxy, building the material complexity that would eventually, across billions of years and countless generations of stars, make worlds like ours possible. There is something almost unbearably moving about this, if you let yourself feel it slowly in the way that sleepiness allows. When the guard of the analytical mind is lowered and things can simply be felt rather than categorized, the atoms in your body, the iron in your blood, the calcium in your bones, the carbon that forms the backbone of every biological molecule that makes you what you are. All of it was forged in stars that exploded billions of years ago. Stars whose supernovae fingerprints we can still read in the spectra of ancient halo stars in a galaxy 2 and 500,000 light-years away. The universe made its heavy elements in fire and distributed them across the darkness. And billions of years later, some of that enriched material found its way into the solar nebula that would become the Sun and the Earth. And billions of years after that, some of that material learned to breathe and wonder and lie down in the dark and listen to a story about stars. And speaking of stories, Andromeda's halo contains something else. Something that speaks not of creation, but of consumption, not of birth, but of the long, slow work of gravitational gathering that has made Andromeda what she is today. Because scattered through that vast halo, woven into its diffuse light like threads of a very old cloth, are structures that astronomers call stellar streams, and they are among the most haunting things in the observable universe. They are haunting, not because they are frightening, but because of what they are, what they were, what they represent in the long, patient story of how galaxies grow. Stellar streams are the remnants of smaller galaxies, dwarf galaxies and globular clusters that wandered too close to Andromeda across the long eons of cosmic time. Drawn in by gravity's quiet insistence, pulled closer and closer until the tidal forces of the larger galaxy began to stretch them, to pull stars from their edges, to unravel them slowly, the way you might unravel a loosely wound ball of thread, drawing out a long, thin line of stars that curves and arcs through the halo. Still following approximately the orbital path of the galaxy that once existed, but no longer bound together, no longer a coherent structure, only a memory, a ghost made of stars, a whisper of something that used to be whole. The evidence in Andromeda's halo suggests that she has consumed dozens of smaller galaxies throughout her history. Dozens of entire stellar systems drawn in across billions of years and unraveled and absorbed, their stars added to the growing halo. Their gas and dark matter merged into the greater whole. Dozens. It is a word that carries weight when you consider what it means. Each of those smaller galaxies was itself a complete system, a collection of millions or billions of stars, each star potentially with planets, each system with its own structure and its own history and its own chemical story. All of it consumed, all of it gathered in, all of it made part of Andromeda. This is how galaxies grow in the standard model of cosmology, not primarily through the gradual accumulation of individual stars, but through the merger and cannibalization of smaller structures. The larger gravitational wells drawing in the smaller ones across cosmic time, building themselves up through a long, patient history of absorption. Andromeda is large and magnificent today in part because of everything she has consumed, because of every smaller galaxy that wandered too close and was unraveled and made part of her halo. They are stars now drifting in slow, ancient orbits far from the disk, carrying the memory of where they came from in their chemical fingerprints and their orbital trajectories. And among all the stellar streams woven through Andromeda's halo, there is one that is so prominent, so clearly defined, so vast and dramatic that it has earned its own name. It is called the Giant Stellar Stream, and it is exactly what its name suggests: a ribbon of stars, a great arc of stellar light that curves around and through the outer halo of Andromeda. One of the most striking features of the galaxy, when viewed in maps that reveal the halo's structure. The Giant Stellar Stream is believed to be the remnant of a dwarf galaxy that was consumed billions of years ago, drawn in and unraveled by Andromeda's tidal forces. Its stars stretched out into this long, curving arc that persists to this day, still tracing the ghost of an orbit that no longer belongs to a living galaxy, still holding its shape across billions of years of slow dissolution. When you look at maps of the Giant Stellar Stream, even knowing what it is and how it formed, there is something that feels almost like recognition, as if this long, pale ribbon of ancient stars is familiar to some deeper part of the mind, the part that thinks in metaphors rather than numbers, the part that is always looking for patterns and stories in the things it observes. A ribbon, a thread, a river of stars flowing through the outer darkness, the light of an entire galaxy, stretched thin and drawn out across the void, still there, still carrying its ancient photons outward through space in all directions, still contributing to the faint glow of the halo that extends so far, it reaches more than halfway to our own galaxy. There is a kind of tenderness in imagining those stars, those billions of individual suns that once belonged to a coherent galaxy with its own gravitational center, its own structure, its own shape in the sky as seen from any worlds that might have orbited within it, now drifting in this long, slow arc through the darkness, no longer bound together in the same way. No longer a galaxy in any meaningful sense, but still there, still burning, still casting their light into the universe as they have been doing for billions of years, long before there was anyone to see them, long after the galaxy they once belonged to ceased to exist as anything other than a memory written in orbital mechanics and chemistry. The halo keeps these memories. It is the oldest part of Andromeda, the part that has been accumulating for the longest time, the part where the universe has been depositing its ancient records, its chemical signatures, its orbital echoes, its ghostly streams. The disk is where the activity is, where the star formation happens, and the spiral arms wind, and the hot young stars blaze in their fierce brief lives. But the halo is where the history is. The halo is the archive. The halo is Andromeda's memory of everything she has been, and everything she has consumed, and everything that came before the world we know. And drifting through that halo, those stellar streams, those long, pale ribbons of stars that were once entire galaxies with their own suns and perhaps their own worlds, now dissolve slowly into Andromeda's halo, the way a whispered word dissolves into silence. And there is something deeply peaceful about that dissolving, about the way nothing in the universe is ever truly lost, but only transformed and gathered in and made part of something larger. The way the boundaries between waking and sleeping are dissolving in you right now, softly and without any effort at all, as the universe continues its patient work of gathering and weaving and slow, magnificent becoming. And it is into that patient work that we now turn our attention, drifting outward from the gentle spiral arms of our own galaxy to look ahead across time itself, across billions of years of deep and unhurried cosmic patience, to a meeting that has been arranged since long before our sun was born, a meeting between two great spirals turning slowly in the dark. And the name of that meeting is something astronomers have watched approaching for decades now, tracing the path of our nearest large neighbor through the void, measuring her speed and her angle and her intention, the way you might watch a ship on the horizon and know with a quiet certainty that it is coming toward you. That neighbor is Andromeda. You may have heard her name before, and perhaps it arrived the way beautiful names often do, trailing something grand and slightly unreal behind it. She is our closest large galactic companion, a spiral like our own Milky Way, containing hundreds of billions of stars of her own, each one a sun, each one perhaps accompanied by worlds in orbit. And she is moving toward us right now, in this very moment, as you rest here in the soft and comfortable dark, moving through the fabric of space at approximately 110 kilometers every second. That is not a small number. 110 kilometers in the time it takes your heart to beat once, in the time it takes you to draw a single slow breath. Andromeda has crossed a distance that would take a fast aircraft many hours to fly. And yet the distances involved are so breathtakingly vast, so incomprehensibly enormous, that even at this speed, the journey she is making will take a long, long time to complete. Roughly 4.5 billion years from now, the outer edges of our two galaxies will begin to truly find each other. And what follows will be one of the most spectacular events the universe can offer. And also, in its own deep way, one of the most serene. Hold that thought for a moment. Hold it gently, the way you might hold a smooth stone in your palm, feeling its weight without gripping it. 4.5 billion years. That is a duration so large, it cannot really be imagined in ordinary terms. Our sun itself is approximately 4.5 billion years old, meaning we are asking you to look forward across an entire lifetime of the sun. In 4.5 billion years, the sun will have changed considerably, growing older and broader in the way of older stars. And the Earth story will have been written to conclusions we cannot fully anticipate. But the solar system itself, that quiet family of worlds arranged around their star, will almost certainly still exist when Andromeda finally arrives at our shores. There is something comforting in that continuity, in the idea that the sun and its worlds will be present to witness this great reunion, even if no eyes remain to look up at the changing sky. And the sky will change. Oh, how the sky will change. Long before the two galaxies are close enough to begin their gravitational conversation in earnest, Andromeda will appear in the night sky of any world with eyes to see. Growing slowly over millions of years, at first, just a slightly brighter smudge among the stars, then a widening band, then a presence that takes up more and more of the sky until it fills half the heavens with its soft and luminous glow. Imagine lying on your back in a field, the way you might lie right now in the comfortable flat landscape of your bed. And above you, instead of the modest oval of Andromeda that observers with dark skies can just make out today, there is instead a great river of light arching from horizon to horizon. A twin to the Milky Way's own band, but grander, closer, impossible to ignore. That is what the night sky would look like in the epochs just before the collision, and it would be one of the most beautiful things any eyes in the universe had ever seen. But here's the part that astronomers find almost paradoxical, the part that sounds like a riddle until you understand the extraordinary emptiness of space. And then it sounds instead like a kind of relief. When these two galaxies containing between them hundreds of billions, perhaps trillions of stars, when these two enormous structures of stellar fire and gas and ancient light come together in what we call a collision, almost no stars will actually collide with each other, not even close to it. The distances between individual stars are so unimaginably vast, so much greater than the stars themselves, that two galaxies can pass through one another like two clouds of fireflies drifting together in an open field, each firefly entirely unaware of the others, each finding its way through the gaps. If you could somehow shrink our sun to the size of a single grain of sand, the nearest star to us, Proxima Centauri, would be another grain of sand more than 4 kilometers away. 4 kilometers of empty space between 2 grains of sand. Now imagine filling a region the size of a small country with such grains, and you begin to understand why two galaxies can merge without their stars destroying each other. The stars themselves are simply too small and too far apart. They drift through the encounter in a kind of quiet safety, and this knowledge settles over the scale of the event like a gentle blanket, making something that sounds violent in its naming into something that is, for the actual inhabitants of the galaxies, simply a slow and profound rearrangement. What will collide, and collide with great consequence, are the vast clouds of gas and dust that drift between the stars, the raw material from which new stars are made. When these clouds meet, they compress, they heat, they collapse inward under their own weight and ignite, and the result is what astronomers call a starburst, a period of rapid and prolific star formation. New suns blazing into existence in numbers and at speeds that far exceed the ordinary gentle pace of star birth. The merger of our two galaxies will likely spark such bursts of creation, lighting up regions of the combined structure with brilliant young stars, blue and hot and enormous. burning through their fuel with the extravagance of youth. There is something moving about this, something that feels almost like metaphor, though it is purely physics. That two things coming together in what might seem like a collision produce not destruction but creation, not an ending but a sudden tremendous flowering of new beginnings. The process itself, this gravitational dance between Andromeda and the Milky Way, will not happen quickly even by cosmic standards. NASA's simulations of the merger, built from our best understanding of physics and the measured properties of both galaxies, show that the two spirals will not simply come together once and settle. Instead, they will approach, pass through each other in a long, slow interpenetration, then separate somewhat, pulled back by gravity, drawn together again, passing through once more, separating again, each passage lasting hundreds of millions of years, each encounter tugging at the shapes of both galaxies, drawing out long tails and streamers of stars, distorting the familiar spiral arms into new and unfamiliar configurations. This gravitational choreography will continue for something on the order of 2 billion years before the two structures finally settle into each other completely and the merging can be called truly finished. 2 billion years of slow, patient, gravitational conversation. 2 billion years of gradual becoming. And what emerges from that long becoming is something different from either of its parents. The two spirals, those beautiful pinwheeling structures with their bright arms and their central bulges, will lose their spiral shapes during the merger as the gravitational disturbances scramble the orderly patterns that made them what they were. What forms instead will be an elliptical galaxy, a great rounded cloud of stars without the dramatic structure of a spiral, more like a softly glowing egg of light than a pinwheel. Enormous and ancient and full of the combined stellar populations of both original galaxies. Scientists have given this future galaxy an affectionate nickname, and it is one that carries within it both of its parents, honoring the lineage from which it came. Some call it Milkomeda, some call it Milkdromeda, and there is something endearing about the fact that even astronomers, those careful keepers of precision and number, could not resist giving a poetic name to this future child of our two spiraling homes. Milkomeda. It sounds like something from a lullaby, like a word you might murmur softly to someone drifting toward sleep. And what of us, of this solar system? This quiet family of worlds arranged around an ordinary yellow star on the edge of one of the Milky Way's arms. What happens to this small and beloved neighborhood when the great merging comes? The answer, remarkably, is this: we will almost certainly survive. The gravitational turbulence of the merger will likely fling our solar system outward, away from wherever we currently reside in the galaxy, sending us tumbling into a new region of the merged Milkomeda, a region we have never visited, a different address in a much larger neighborhood. We may find ourselves far from the galactic center, or we may be swept closer to it, and the night sky, as seen from any worlds in our system, will be transformed beyond recognition. The familiar constellations long since scattered by the proper motions of stars over billions of years, replaced by a sky dominated by the enormous glowing body of the merged galaxy surrounding us on all sides. But the sun will still be the sun. The planets will still be the planets. The gravitational family of our solar system, that intimate bond between a star and its worlds, will remain intact through the encounter, as close and as whole as it ever was. Carried together into its new address, the way a household might be moved to a new city, everything inside still belonging to each other, still warm and familiar. Even if the view from the window is entirely new, There is a gentleness to this that perhaps we did not expect when we first heard the word collision. A gentleness that the universe has hidden inside what sounds like catastrophe. The way sleep hides inside what feels like restlessness, waiting patiently for the right moment to emerge. The great collision of Andromeda and the Milky Way is not a story of destruction. It is a story of transformation, of two vast and beautiful things becoming one vaster and more beautiful thing, of stars finding new neighbors, of gas clouds meeting and sparking new suns into being, of the universe continuing its patient and inexhaustible work of creating complexity from simplicity, form from formlessness, light from darkness and from dust. It is, in its own enormous and unhurried way, a love story between galaxies, a coming together that has been written in gravity since before our star was born. Inevitable and slow and ultimately generative, the way the most important changes in any life tend to be, not sudden and violent, but gradual and deep, reshaping everything so slowly that you only notice it has happened long after the reshaping is complete. And so the universe holds this future in its patient hands, billions of years from now, two spirals becoming one ellipse, the familiar sky dissolving into something grander and stranger. New stars burning brightly in the spaces where gas clouds have met and collapsed and kindled, the entire merged structure settling slowly into its new shape, like sand settling at the bottom of a still and quiet sea. And somewhere within all of that, our small sun and its companion worlds drifting through their new address in the new galaxy. The same sun that rose this morning over whatever horizon you know best. The same sun that will set this evening and give way to the stars you are perhaps imagining right now as you rest. And in that merged galaxy, in that gentle, slow-motion catastrophe that is really no catastrophe at all, but simply a reunion of two families of stars. New stars will be born in great bursts of creation as gas clouds collide and compress, and the night sky, as seen from any world within the new galaxy, will be blazing with new suns. A sky so full of light that the darkness between stars would seem almost like a memory, almost like the quiet, comfortable darkness you're resting in now, which is itself full of, and in that merged galaxy, in that gentle, slow-motion catastrophe, that is really no catastrophe at all, but simply a reunion of two families of stars. New stars will be born in great bursts of creation as gas clouds collide and compress, and the night sky, as seen from any world within the new galaxy, will be blazing with new suns. A sky so full of light that the darkness between stars would seem almost like a memory, almost like the quiet, comfortable darkness you're resting in now, which is itself full of possibility, full of unseen things, full of the same patient mystery that fills the space between Andromeda and us, that 2.5 million light-year corridor of almost nothing, which is, when you think about it gently and without rushing, also full of everything that has ever mattered. Light, time, the soft insistence of gravity, pulling two galaxies slowly toward each other. And somewhere within that vast spiral of light we call Andromeda, somewhere within its wheel of approximately 1 trillion stars, there may be worlds. There almost certainly are worlds. So many worlds that the number loses its edges and becomes more like a feeling than a figure, more like the sensation of standing at the shore of an ocean you cannot see the end of, hearing the waves arrive one after another in the dark. We know this because of what we have learned closer to home. The Kepler Space Telescope, that small patient instrument we sent out into the dark to watch stars blink, taught us something extraordinary in the years it spent quietly counting. It taught us that most stars, most of the ordinary sun-like stars scattered across the cosmos, have at least one planet orbiting them, at least one world. This was not what everyone expected. There were scientists who thought planetary systems might be rare, might be accidents, might be the exception rather than the rule. But Kepler watched and counted and reported back, and what it told us changed the way we understand the universe. Planets are not rare. Planets are what happens when stars form. They are almost inevitable, the way a puddle left in sunlight almost inevitably evaporates, the way a seed placed in good soil almost inevitably reaches toward the light. Stars and planets seem to go together the way sleep and dreams go together, paired by some deep and ancient principle we are only beginning to understand. And if that is true here in our own galaxy, then we carry that understanding across the dark distance to Andromeda, and we hold it gently up to that spiral of light. And we let the mathematics breathe. 1 trillion stars. Most stars with at least one planet. The total number of worlds in Andromeda becomes something almost incomprehensible. A number so large it stops being a number and starts being a kind of wonder. Hundreds of billions of planets drifting in their slow orbits around their patient stars, each one a world with its own gravity and its own sky and its own particular quality of silence. And not just any worlds. Among those hundreds of billions of planets, some fraction, perhaps a great many, would orbit stars in what astronomers gently call the habitable zone. That comfortable distance from a star where water, that quiet miracle, can exist as a liquid on the surface of a world, not boiled away into vapor, not locked forever into ice, just water. The way we know it, moving and pooling and finding its way into every small hollow, the way water always does. Many of Andromeda's stars fall within the right age range, old enough that rocky planets would have had time to form and cool and settle, and they carry within them the right chemical compositions, the heavier elements that are the building materials of life as we understand it. Carbon, oxygen, nitrogen. The ingredients are there, scattered through Andromeda's spiral arms, the way flour and sugar might sit on a shelf, waiting for something to begin. There is even, and this is a detail so quietly remarkable that it deserves to be held in the mind for a moment before you let it drift away into sleep, there is even a candidate, a single extraordinary candidate. In 2009, a team of astronomers studying Andromeda detected something unusual using a technique called gravitational microlensing, which is itself a beautiful concept. The idea that the gravity of a massive object can bend and brighten the light of something behind it, the way a glass of water can bend the image of whatever lies beyond it. They watched the light from a star in Andromeda change in a very particular way, a way consistent with a planet passing in front of it. What they may have detected was the first planet ever found beyond our own galaxy, the first extragalactic planet candidate, a single world, or what might be a world, orbiting a star that is 2.5 million light-years away. Think of that for a moment, gently, without urgency. Think of sitting in a room with the lights low and the sounds of the world quieted, and understanding that the light you collect in a telescope, the light that curves around a star and tells you a planet might be there, that light has been traveling for longer than our species has existed, longer than our planet has had the creatures that would eventually build telescopes and point them at the sky, and still it arrived. Still it carried its message across all that dark distance, and settled into an instrument built by curious hands and told its small and enormous story. We do not know if that planet is real. The signal was consistent with a planet, but gravitational microlensing events are rare and fleeting and difficult to confirm. The candidate exists in the literature with the particular quiet dignity of things that might be true, things that have not been disproven but have not been proven, things that live in the honest, uncertain space that science makes room for. But even the possibility is enough to rest inside for a while. Even the possibility is a kind of gift, because here is something that the mind, drifting toward sleep, might find gently astonishing. If there are worlds in Andromeda, and there almost certainly are, and if any of those worlds have given rise to something we might call life, even the simplest life, even the kind of life that exists only as a thin sheen of chemistry on the surface of a warm, wet rock, then the evidence of that life is already traveling toward us. The light reflecting off those worlds, the chemical signatures of whatever breathes or grows or simply exists in the atmospheres of those distant planets. All of that information is encoded in light that left its source millions of years ago and is even now moving through the dark at the only speed light knows, the only speed that is its nature. It will not arrive for millions of years. By the time that light reaches us or reaches whatever is here to receive it, our galaxy and Andromeda will have already begun their long gravitational dance, will already be drawing closer, will perhaps have already begun to blur together at their edges. The universe operates on timescales that make patience feel like an art form, like something to be admired rather than simply practiced. But the light is coming. That is the quiet and remarkable thing. Somewhere in the dark between us, there may already be, right now as you lie here, as your breathing slows and deepens, there may already be light carrying the story of other worlds, passing silently through the space between galaxies, carrying its cargo of information through the dark, the way a letter carries its message across distance, patient, unhurried, faithful to the moment it was written. And there is something in this that feels less like loneliness and more like correspondence, like two minds separated by an enormous table writing letters to each other without knowing if the other is there. The act of writing the letter, the act of light leaving a world and beginning its journey, that act does not require a reader to be meaningful. The light goes anyway. It carries what it carries. It moves at its constant speed through the constant dark, and it does not hurry, and it does not slow, and it does not know anything about the billions of years it will travel before it arrives somewhere that can receive it. This is perhaps the deepest thing about Andromeda, the thing that makes it more than just a beautiful smudge of light in the sky on a clear night. It is a reminder that the universe does not wait for us to be ready. That process is enormous and slow and magnificent, are already underway, have always been underway, were underway before there were eyes to see them, or minds to understand them, or words to describe them. The stars in Andromeda have been burning for billions of years without anyone in this galaxy knowing their names. The planets, if they are there, have been completing their quiet orbits, season after season, year after year, in whatever calendar their sun might suggest, for longer than we can comfortably imagine. And all of it has been happening in a kind of perfect privacy. A privacy that is not secrecy, but simply distance, simply the ordinary condition of things that are far away. But distance is not the same as absence. That is worth remembering in the gentlest possible way as the mind grows quieter and the body grows heavier against whatever it is resting on. Distance is not absence. Andromeda is not absent from our universe simply because it is far. Its light is here, in our eyes, in our telescopes, in the photographs taken by patient astronomers who stayed up through cold nights to collect it. Its gravity is here, gently influencing the motion of our galaxy in ways too subtle to feel, but not too subtle to measure. And if its worlds carry life, then perhaps what those worlds carry is here too, in some form, already traveling, already on its way, already part of the long conversation the universe is having with itself across the dark. There is a kind of comfort in this, a comfort that does not require certainty to be real. We do not need to know that life exists in Andromeda to feel the warmth of the possibility. We do not need to receive that light to know it might be coming. The universe has arranged things so that even the questions are beautiful. Even the not knowing has a texture and a weight that feels in the right mood, in the right quiet. Almost like knowing. Almost like the feeling you have sometimes at the edge of sleep, when you cannot quite tell if you're thinking a thought or beginning to dream it. When the boundary between the mind that asks and the mind that simply rests becomes soft and permeable and kind. And so we rest here in the comfortable dark, knowing that Andromeda is out there, that extraordinary galaxy with its trillion stars and its hundreds of billions of possible worlds, its ancient light and its approaching gravity, its 2009 planet candidate holding its uncertain place in the literature of what might be true. All of it is out there, unhurried, beautiful, operating on its own vast time scale, moving through its own long story, which is also our story because we share a universe. Because gravity connects everything to everything else in a web, so large and so gentle that we can spend our whole lives inside it without feeling its shape. And the worlds within Andromeda, those hypothetical worlds orbiting their patient stars in their quiet habitable zones, those worlds are out there too, or something very much like them is, turning slowly on their axes, facing their suns and turning away from their suns in whatever rhythm their days have established over millions of years. And on some of those worlds, if the universe is as generous as the numbers suggest it might be, there might be surfaces. Surfaces with textures. Surfaces that catch and hold whatever light falls on them. And on some of those surfaces there might be the quiet chemistry that precedes life, or the louder, more complicated chemistry that is life, doing what life does, which is essentially to organize itself against the drift toward disorder, to find a shape and hold it for a while, to use energy and matter to persist. We cannot know. We may never know. The distances involved are so vast that even our fastest spacecraft, the ones we have already sent out past the edge of our solar system, would take tens of thousands of years to reach the nearest star in our own galaxy, let alone another galaxy entirely. Andromeda is so far that it exists for us almost entirely as light, as information carried by photons across a void that no living thing we know of has ever crossed. It is a neighbor we know only by its glow, the way you might know a light in a distant house, warm in a dark landscape, and feel a connection to it, despite never having spoken to whoever lives there. But knowing only by glow is still knowing, and the glow is real, and the trillion stars are real, and the hundreds of billions of possible worlds are, if not proven, at least mathematically probable in a way that feels like more than wishful thinking. It feels like the universe extending something toward us, some kind of quiet offer, the offer of scale and possibility, and the particular kind of humility that comes from understanding how many chances there have been, how many places and times and arrangements of matter the universe has tried, how unlikely it would be. Given all of that, for curiosity to exist only here, and perhaps on one of those worlds, orbiting one of those trillion stars, something is resting in its own form of darkness and looking outward at its own smudge of light in the sky, which is this galaxy, our galaxy, and wondering the same slow, wondering questions that drift through the half-sleeping mind. Questions that do not need answers to be beautiful. Questions like whether the universe is lonely, or whether it has always been perfectly and completely full of itself, the way sleep is full of. And perhaps on one of those worlds, orbiting one of those trillion stars, something is resting in its own form of darkness and looking outward at its own smudge of light in the sky, which is this galaxy, our galaxy, and wondering the same slow, wondering questions that drift through the half-sleeping mind, questions that do not need answers to be beautiful. Questions like whether the universe is lonely, or whether it has always been perfectly and completely full of itself, the way sleep is full of. Its own soft world, a world with its own geography of shadows and warmth, its own territories mapped not by instruments but by feeling. And it is that feeling, that particular trembling at the edge of understanding, that brings us now to a quieter kind of story. Not a story about the stars themselves, but about the people who looked at them, about the long and tender history of how we came to know what Andromeda really is, how it rose from mystery into meaning across the slow centuries. The way a figure slowly becomes recognizable in a dark room as your eyes adjust, as the dark gives up its secrets, one soft increment at a time. For most of human history, Andromeda was simply a smear of light in the autumn sky. Ancient astronomers noted it. Persian astronomers wrote of it as a small cloud near the constellation that bore its name. For 1,000 years it floated in the catalogs of the sky, patient and unnamed in its true nature, filed away in the ledgers of stargazers as a curiosity, a nebula, which simply means cloud in Latin, a word that captures perfectly the way we name things we do not yet understand. We call them clouds when we cannot see their shape. We call them mysteries when we cannot hold them. We let them sit at the edge of knowledge, the way certain memories sit at the edge of waking, present and soft, and not quite graspable. In the 18th and 19th centuries, as telescopes grew longer and eyes grew more practiced, the nebulae became objects of serious study. Charles Messier, a French astronomer hunting comets in the cold Paris nights of the 1700s, catalogued Andromeda as Messier 31, listing it alongside dozens of other smudges and spirals that he wanted to note down so he would not mistake them for the comets he was truly searching for. There is something wonderfully accidental about this, something that happens in the long history of discovery, where the thing you were not looking for turns out to be the most astonishing thing of all. Messier was keeping a list of distractions, and in doing so he gave the world a map to the universe. Through the 19th century, telescopes improved and the nebulae resolved into shapes. Astronomers noticed that many of them had a particular form, a bright center with arms of lighter material curving outward in a graceful spiral, like a pinwheel held up to a lamp, like the slow turning of something very large seen from very far away. These were called spiral nebulae, and the assumption, quite natural given everything that was known at the time, was that they existed within the Milky Way itself. The Milky Way was understood to be the whole of the universe, and so everything that could be seen must live within it. The way everything you can touch in a room must be in the room with you. The spiral nebulae were thought to be perhaps young solar systems forming, clouds of gas condensing into stars and planets, the birth material of worlds being shaped by gravity into something new. This was not a careless assumption. It was a reasonable one, drawn from everything then known, and it sat comfortably at the center of astronomical thinking for decades, warm and undisturbed. The way a wrong answer can sit perfectly still if no one yet has the right question. The universe was the Milky Way. The Milky Way was the universe. Everything seen in the sky was part of one great family of stars, and the spiral nebulae were simply cousins, younger relations, clouds in the process of becoming something solid. But there were people who doubted this, quietly, the way doubt often begins, not with loud argument, but with a persistent feeling that the numbers do not quite add up, that the measurements refuse to arrange themselves neatly into the shape of the accepted answer. And so the question began to circulate delicately at first among those who made their living reading the sky. Could some of these nebulae be far outside the Milky Way? Could they be not clouds within a galaxy, but entire other galaxies? Islands of stars unto themselves, each one holding as many suns as our own great spiral. Each one floating in the dark at distances so vast they defied easy imagining. This question grew serious enough that in 1920 it became the subject of a formal scientific debate between two astronomers, Harlow Shapley and Heber Curtis, who stood before their colleagues and argued, with all the careful evidence they could assemble, for their opposing views of the cosmos. Shapley believed the spiral nebulae were local, part of our own galaxy, a galaxy he estimated to be enormous, larger than anyone had previously imagined. Curtis believed the opposite, that the spiral nebulae were external galaxies, island universes, each as grand and complete as our own. They called this the Great Debate, and at its end no one had quite won, because the evidence at that moment was not yet strong enough to decide the matter cleanly. The question floated on, unresolved, like a question whispered into a dark room and not yet answered by anything but the patient sound of breathing. The answer, when it came, was made possible by the work of a woman who had done her most important science years before the debate even took place, and whose name was not as celebrated in her lifetime as the giants who came after her, but whose contribution was as foundational as the ground beneath an observatory, as necessary as glass to a telescope. Her name was Henrietta Swan Leavitt, and she worked at the Harvard College Observatory in the early years of the 20th century as a human computer, one of a group of women hired to analyze photographic plates of stars, to measure and record and classify. Work that was painstaking and meticulous, and often overlooked in the way that essential labor is often overlooked, the way we forget the hands that set the stage before the performance begins. Leavitt was studying a particular kind of star called a Cepheid variable, a star that brightens and dims in a regular rhythm, pulsing like a slow heartbeat, like a lamp being turned up and down on a timer. These stars had been known for some time, but their true usefulness had not yet been understood. Leavitt noticed something extraordinary while studying Cepheids in the small Magellanic Cloud. She noticed that the brighter ones took longer to complete their cycle of brightening and dimming, and that this relationship was not random, but precise. A clean and reliable mathematical connection between how long a star pulsed and how luminous it truly was. This is called the period luminosity relationship, and it is one of the most elegant discoveries in all of astronomy, a cosmic ruler, a way of measuring distance by observing behavior. The way you can judge how far away a lighthouse is not by its apparent brightness alone, but by knowing its true power. If you know how bright a Cepheid star truly is, and you can see how bright it appears, then the difference between those two numbers tells you how far the light has had to travel to reach you. Distance, that most elusive of astronomical measurements, had been given a key. Leavitt did not fully develop the cosmological implications of this herself. She measured, and she noted, and she published, and the world took her discovery and carried it forward in the hands of others who were given more tools and more telescopes and more time. There is a quietness to her story that feels important to hold. A recognition that the architecture of our understanding of the universe was built by many hands, not all of them remembered equally. Not all of them standing in the front of the room when the applause came. The person who used Leavitt's ruler to settle the great debate was Edwin Hubble, who in 1923 turned one of the most powerful telescopes in the world toward the Andromeda Nebula and searched its outer edges for Cepheid variable stars. He found them. He measured their periods and applied Leavitt's relationship and calculated how far away they must be, and the number that came back was staggering. Andromeda was not within the Milky Way. It was not a neighboring cloud of gas condensing into infant solar systems. It was nearly 1 million light-years away, though we now know the true distance is closer to 2.5 million. A testament to the difficulty of measuring such immense spans of space, even with the best tools available. What mattered in that moment was the order of the answer. Andromeda was far, incomprehensibly far, further than the Milky Way extended in any direction, which meant it could not be inside the Milky Way at all. It was outside. It was separate. It was an entire other galaxy, a whole other island universe of hundreds of billions of stars, floating in the dark at a distance that required new kinds of language even to speak of. The universe, in a single measurement made on a cold California night, became unimaginably larger. What had been the whole cosmos became merely one galaxy among many, the Milky Way, which astronomers had been working to understand as the entirety of creation, revealed itself overnight to be just one resident of a vastly larger neighborhood, one island in an ocean of islands, one congregation of stars among what would turn out to be hundreds of billions of other congregations spread across the observable universe in every direction, stretching back toward a beginning so distant in time that the light from those first galaxies has been traveling toward us since before the Earth was born. Hubble published his findings in 1924 and the great debate was resolved. The universe was larger than anyone had imagined. This is a phrase that has been true so many times in the history of science that it has become almost a refrain, a recurring theme in the long music of discovery. Each time we look harder and deeper, the universe is larger than we imagined. Each time we build a better instrument, the darkness turns out to be full of more. And each time, there is a period of adjustment, a moment of collective breath, as human minds stretch themselves to accommodate the new scale of things. The way you take a breath before diving into deep water, steadying yourself for the depth that awaits. The story of knowing Andromeda did not end there. It has continued through every decade since, growing richer and more detailed as instruments grew more powerful. The Hubble Space Telescope, lifted above the blurring atmosphere of Earth and placed in clear orbit among the stars, has photographed Andromeda in extraordinary detail, resolving individual stars in its outer halo, counting the clusters of ancient suns that orbited like quiet attendants, mapping the structure of its spiral arms with a precision that would have seemed miraculous to Hubble the man. for whom seeing Cepheids at all required straining at the very limit of what was then possible. The Spitzer Space Telescope, sensitive to the warmth of infrared light, has peered through the dust of Andromeda's disk and seen the heat of star formation. The warm nurseries where new stars are being assembled, even now, from the ancient material of the galaxy's clouds. The Chandra X-ray Observatory has detected the high-energy signatures of Andromeda's most violent residents, the neutron stars and black holes and hot gas that fill its deepest regions, with a kind of light the human eye will never see, but that instruments translate faithfully into pictures that carry their own strange beauty, a beauty that does not require color vision to appreciate, but only the willingness to understand that the universe speaks in wavelengths beyond our sight, that there is more light in the world than we were built to see. Each of these instruments has added a layer to our picture of Andromeda, the way an artist adds layers to a painting, each one deepening the color and the texture until the canvas holds something that approaches the true richness of its subject. And what began as a small cloud in a Persian astronomer's notes, what was filed as a curiosity by a French comet hunter, what was argued over in a formal debate between two careful men, what was finally measured by the light of a pulsing star in the clear dark of a California mountain, has become one of the most thoroughly studied objects in the entire sky. A galaxy we know in many wavelengths, a neighbor we have learned to recognize in the dark, and there is something deeply moving about this arc, this long human arc from noticing to understanding, from a smudge seen by naked eyes thousands of years ago to a detailed portrait assembled across every color of light by instruments that float in space or sit on mountaintops in the thin, cold air where the seeing is best. The people along this arc were dreamers and measurers, women who counted stars in basements, and men who climbed into observatory domes in the winter dark. And all of them were doing the same thing underneath. They were refusing to let the mystery stay mysterious. They were insisting with the particular human stubbornness that looks most like love that the sky should not be allowed to keep its secrets forever. And it was that very human need to understand, that quiet insistence on looking upward and asking what is that light and how far away is it and are we alone in all of this, that slowly over centuries of patient watching built the picture of Andromeda that we now carry inside us. A picture made not just of data and mathematics, but of every person who ever stood in the dark and felt something lift in their chest at the sight of that faint smudge of ancient light. And now that knowledge rests in you too, settling gently into the deeper layers of the mind, the way starlight settles onto the ground after a long night of falling, absorbed quietly and completely, becoming part of the very surface it touches. And now here, in this particular moment, in whatever quiet place you have found for yourself tonight, with the weight of the day beginning to soften at the edges and your breath slowing into something more ancient than thought, you are already beginning the journey that every human being takes each night, that long and necessary turning inward, that mirrors in its own small way the great turning of galaxies in the dark. Close your eyes if you have not already. Let the muscles around them release, those small, faithful muscles that have been working all day, pulling focus near and far, reading light, interpreting shadow, tracking the 1,000 small movements of the world. Let them rest now. Let everything that is held be, for this little while, gently set down. Because tonight, as you drift, something remarkable is already beginning to happen inside you. The brain, that extraordinary and tender organ, resting at the center of your experience, is beginning a kind of work that only sleep can do. Researchers who study the sleeping mind have found that this is not a time of absence, not a blank and empty pause between the days, but a time of deep and purposeful activity. A time when everything you have taken in, every fact and feeling, every image and idea, is quietly sorted and woven and laid into the longer fabric of what you know and who you are. The things you learned tonight, the distance of Andromeda, 2.5 million light-years of genuine, measurable, breathtaking space. The way its light has been traveling since before our earliest ancestors stood upright on the African savanna, the way it is moving toward us even now in the long, slow drift of gravity's embrace. All of this is being carried gently into the deeper structures of your memory. The hippocampus, that curved and seahorse-shaped region tucked within the temporal lobe, is passing information to the cortex during sleep, allowing the brain to consolidate what was new into what is lasting, weaving each strand of knowledge into the larger pattern of long-term understanding, the way a weaver works in the quiet hours after. The market has closed, and the noise of the day has finally gone still. This is what sleep does. It does not merely rest you, it completes you. Each night, the mind does the work that waking cannot, finding the connections between things, drawing the threads tighter, making a kind of sense that consciousness alone, busy and distracted and always moving forward, rarely has the time or the stillness to make. And so the story of Andromeda, the one you have been holding tonight, will not simply fade when morning comes. It will be there in a deeper place, changed in texture. Part of you, in a way, it was not this afternoon. There is another kind of work happening too. One that is quieter still, one that the body does without any instruction from the thinking mind at all. The glymphatic system, a network of channels that runs alongside the brain's blood vessels, becomes significantly more active during sleep. It is a kind of clearing system, a gentle tide that moves through the spaces between cells and washes away the metabolic waste that accumulates during the day, the byproducts of all that thinking and perceiving and feeling, flushed slowly and carefully away. Scientists sometimes call it the brain's cleaning cycle, and there is something almost tender about that. This idea that while you dream, the mind is being quietly restored, made clean and ready for another day of wondering. It is housekeeping of the most intimate kind, and it happens only here, only in this soft and necessary darkness. Think of it, if you like, as the universe taking care of itself, because that is not entirely a metaphor. The same processes that govern the recycling of matter in space, the way stars exhaust themselves and release their elements back into the interstellar medium to be gathered again and shaped into new stars, new planets, new possibilities, those processes are mirrored in the cycling of your own body's chemistry, in the nightly clearing that makes room for what comes next. Nothing in the universe, not the largest spiral galaxy burning with 1 trillion suns, not the smallest sleeping mammal curled in the dark, nothing wastes what it has made. Everything is returned, everything is reused, everything is, in the end, part of the same patient conversation between matter and time. And that brings us to something that is worth carrying gently into sleep. Something that is not a metaphor, not a poetic flourish, not a way of speaking loosely about belonging, but a literal and measurable and extraordinary fact. The atoms in your body, the carbon that forms the long chains of your DNA, the oxygen moving even now through your bloodstream, the nitrogen threaded through your proteins, the iron that gives your blood its color and its purpose. These atoms were forged in stars. not metaphorically forged, not in some distant ancestral sense, but actually made in the nuclear furnaces of stars that burned and died long before our sun was born. They were scattered into space. They drifted. They gathered into clouds. They collapsed under gravity into new stars, new planets, new oceans, new life, new you. And those same elements, carbon and oxygen and nitrogen and iron and all the rest, are found throughout the stars of Andromeda. Andromeda's trillion stars are burning with them, building with them, seeding the space around them with them. When you look at Andromeda, you are looking at something made of the same fundamental material as your own body. You are, in the most literal scientific sense that those words can carry, made of the same stuff as that ancient and enormous and beautiful galaxy. The distance between you is real. Yes, 2.5 million light years of genuine and staggering space. But the kinship is also real, equally measurable, equally true. There is something that researchers who study human psychology have begun to document in recent years, a state of mind that they call awe, and they have found that looking at the night sky, really looking in the way that opens rather than closes, reliably induces it. Studies have measured what happens in the body when a person stands beneath an open sky and lets it in. Cortisol levels, the markers of stress and urgency, and the body's constant low hum of alarm, drop. The nervous system shifts from its vigilant state into something quieter. People report feeling smaller, but not in a diminishing way. Smaller in the way that releases rather than contracts. Smaller in the way that makes it easier to breathe, to let go. To set down the particular and exhausting fiction that any of us are separate from the rest of what is happening in this vast and luminous universe. That is what you have been doing tonight, in your own way, in this quiet hour. You have been practicing awe, and the body has been responding to it, the way the body always responds to what is true and large and beautiful, by settling, by softening, by releasing the grip. Andromeda is out there now, even as you lie here in the dark. If you were to step outside and find a patch of sky away from the lights, and if the night were clear and your eyes were patient, you would see it, or nearly see it. That faint and ghostly smudge in the constellation Andromeda, visible to the naked eye if you know where to look. The most distant thing a human being can see without any instrument at all. 2.5 million light years of traveled time, arriving at your eyes as a pale suggestion as light that left its source before anything that would eventually become you had yet emerged from the long evolutionary story of life on this planet. And here it is. And here you are. And the light is still arriving. Let that image settle over you now like something soft. Andromeda out there in the dark, wheeling slowly in its enormous orbit around its own center. Its hundreds of billions of stars moving in the long, slow choreography of gravity. Its light streaming outward in all directions. A small fraction of it falling, always falling, toward this little world, toward this particular night, toward wherever you are lying right now, in the warmth and the dark. You do not have to do anything with that. You do not have to understand it fully, or hold it precisely, or fit it neatly into any larger framework. You can simply let it be true. You can simply let it rest beside you, the way you might rest beside something very old and very beautiful, without needing to explain it, without needing to summarize it, without needing anything from it at all, except its quiet and enormous company. The breath moves in and moves out. The body grows heavier against whatever is beneath you. The mind begins to loosen its grip on the sequential, the logical, the daylit, and to move toward that other country, the one that does not have a name in any language but that every human being visits every night. That borderland between the known and the not yet dreamed, where the self becomes fluid and the stories that seemed fixed begin to move and shimmer and take on new shapes. In that country tonight, perhaps Andromeda will appear in some form you would not expect. Not a diagram, not a data point. Perhaps just a quality of light, a sense of depth and spaciousness, a feeling of moving very slowly through something very large and very quiet and very kind. The dreaming mind takes what we have given it and finds its own way through it, its own images, its own understanding, and whatever it makes of Andromeda tonight will be yours and only yours. A private conversation between a sleeping human being and the oldest light in the visible sky. Your carbon is resting now. The oxygen in your blood is doing its ancient work without you needing to ask it to. The nitrogen in your cells is holding its patient shapes, and somewhere unimaginably far away, the same elements are burning in stars that have never heard of sleep or dreaming or the particular beauty of lying down in the dark and releasing the day. And yet they are your kin, and they are out there, and the distance between you is real, but it has never once meant that you are separate. This is the thing that science, at its most honest and its most generous, keeps discovering, that the universe is not a collection of separate things arranged in space, but a single event unfolding from a single beginning, differentiated into extraordinary variety, stars and stones and sleeping mammals and spiral galaxies and the quiet electrical murmur of a human mind drifting toward rest. All of it made of the same original matter, all of it following the same original laws, all of it. In some sense, that is both scientific and something more than scientific. One thing looking at itself from a trillion different angles, finding itself over and over beautiful. Let that be the last thought, if it wants to be. Not a conclusion, not a summary. Just a resting place in the middle of something much larger than any single night. In the middle of a universe that is still unfolding, still expanding, still finding new ways to be astonished by itself, while you, made of stardust and questions and the long, slow inheritance of every living thing that came before you, rest inside it, belonging completely, held without effort, quietly home. The light of Andromeda is still falling, gentle as it always has been, onto a world where someone very much like you is sleeping. And so our quiet journey through the soft glow of Andromeda gently comes to rest, like starlight settling on still water. If sleep has already found you, drift deeper now, carried by the slow turning of galaxies. And if you're still here, the next chapter waits whenever you are ready. For now, let the stars keep watch. Good night, dear one. Sleep beautifully.